Hello guys, we're going to go over page number 19 in your notes. You need a calculator, you need a periodic table, you need something to write with. Let's jump right in. So we're going to learn about mole conversions, okay? And this is review from last year. So if we are given, let's say I have the mass of my sample, of my compound. Because I have the mass of something, because we know the molar mass of all the elements on the periodic table, we can figure out how many individual atoms are within that compound, or molecules, or particles, or ions, or formula units. All of these things we can figure out because we know that the molar mass of each of the elements on the periodic table. So we're going to practice using this. Remember that moles is often abbreviated MOL. So if you see MOL, that just means moles. Okay. So let's see here. It says we can use dimensional analysis to convert between moles, grams, and atoms. We know that 1 mole is equal to the molar mass in grams. We also know that 1 mole is equal to 6.022 times 10 to the 23rd particles, whether that is, and when I say particles, I mean atoms, molecules, particles, ions, formula units. Any of these words that you see in a problem, that means you're going to be using this number here, okay? Let's do some examples. Example 1, if a balloon contains 0.400 grams of helium, how many moles of helium are in that balloon? Okay, so what we're going to do is we're going to take the number that we are given here. Okay, and we're going to write it over here to the left, 0.400, and we're going to abbreviate grams, and then helium, we're going to put HE. So see how it says every number needs a unit and a substance? Here's my unit, here's my substance. Okay, so this is our given. It's what the problem gave you. It's the number given to you in the problem. So you're going to take what you're given, and you're going to put it over 1. It wants to know how many moles there are. So we're given grams. We were asked to find moles. So we're going to use the molar mass, okay? So what we're going to do is we're going to set up our conversion factor here. We're going to go times, and then put another one of these, okay? Because I have grams of helium here, I'm just going to look at, don't even worry about the numbers for now. Because I have grams of helium here, I have to have grams of helium down here on the diagonal, because that's the only way to get it to cancel out. So whatever unit and substance you have on top has to go on bottom. These two have to match up, okay? And that's what we have important basically for the rest of the school year, is that your diagonals need to match up. Okay, now whatever you're looking for goes on top. So we're going from grams to moles. We're looking for moles, so moles of helium is going to go on top, okay? See how I filled in my units and my substances before I even touched my numbers? That's what you should do, okay? Now, I know that wherever I see grams, what I tell myself is that G for grams stands for go to the periodic table. Go to the periodic table. So I'm going to go to the periodic table, and I'm going to find helium, and that is 4.00 grams per mole, okay, per 1 mole. So everywhere you see the word mole, you're going to put a 1, okay? And you'll start to pick up on these patterns here as we go through a few more problems, okay? So my grams of helium cancel. I'm left with moles of helium, which is good. That's what I'm looking for. So now I'm going to put this in my calculator. So I'm going to go 0.400, and then if it's on the bottom, you have to divide. So I'm going to, and the 1, yes, I can multiply times 1, but is that going to change anything? Nope. Okay, so I multiply times 1, but now I need to divide by the bottom. Again, here's a 1 here, so it's not going to affect anything. So I'm going to divide by 4.00. And I get 0.1. So that is my answer, 0.1. Now, hold on. I have to look at my sig figs, because it says right here, don't forget to round your final answers to the correct sig figs. So I look at my original number, which has 3 sig figs, because these zeros count, that 0 doesn't. So I need to have, this needs to have 3 sig figs. So I need to add 2 zeros there, okay? And then moles of helium. That's my unit. Helium is my substance. Okay, that's how we do that. Okay, let's do example number 2. So it says a diamond contains 0.090 moles of carbon. What's the mass of the diamond? Okay. So all of these examples on the front are from moles to mass or mass to moles, okay? So let's take what we're given, 0.090 moles. Remember, MOL is an abbreviation for moles, and then carbon is capital C. Okay, take what you're given, put it over 1. Okay, so we're going from moles to mass. That's grams, right? We know that grams measures mass. So because I have moles of carbon here, I know I need moles of carbon here. Okay, because your diagonal units need to match up in order for them to cancel out. Whatever I'm looking for goes on top. So what units am I looking for? I'm looking for grams of carbon because the diamond is made of carbon, so I'm looking for grams of carbon. Okay, notice I did my units before I even filled in the numbers. Okay, so now I'm going to fill in the numbers. Wherever I see G for grams, G reminds me to go to the periodic table. Go to the periodic table, and the molar mass of carbon is 12.01. And then wherever I see mole, I'm going to put a 1. Okay, moles of carbon cancel, and I get, let's put this in our calculator, I'm going to go 0.090 times 12.01, and I get this number here. I'll write my unrounded answer first. I'd like for you guys to write the unrounded one, and then we'll round to the correct sig figs. So this has 2 sig figs. This one has 2 sig figs. Okay, because the 0 on the end counts because there's a decimal, the leading zeros don't count. Because this has 2 sig figs, we need to round to 2 sig figs. So we'll look at our third sig fig over, which is 8. That's going to bump it up. So it's going to be 1.1 grams of carbon. Okay? Okay. Let's do another example. A nail contains 1.7 times 10 to the negative 4 moles of iron. How many grams of iron are in the nail? Okay, so let's take what we're given, 1.7 times 10 to the negative 4 moles of iron. Iron is Fe. Take what I'm given, put it over 1. Okay? It's asking us to find grams of iron. Okay, so I have moles of Fe here. So I already, without even thinking, I should know that moles of Fe go down here because your diagonals need to match up so they cancel out. Now I put whatever I'm looking for goes on top. I'm looking for grams of iron. So grams of iron goes on top. Okay, now I can fill in the numbers. G for grams tells me to go to the periodic table. Fe has a molar mass of 55.85. Wherever I see the word mole, I'm going to put a 1. Okay, grams per mole, good. These guys cancel. Let's do the math. So 1.7, now remember, this is scientific notation, so I use my E button. E stands for times 10 to the negative 4. Okay, if you want to see how I did that, I went negative 4. Okay, and then I'm going to go times 55.85. And that's what I get. Let me write that down. 0.009. I'm writing my unrounded answer first. Guys, keep your work neat. It is so important. Okay. Okay. Let's figure out how many sig figs we need. This number here, you always look at what comes before the times. This has 2 sig figs. 2 sig figs. So I need 2 sig figs here. So I could round this to, remember the leading zeros aren't significant. So 0.009, and then this 9 would bump that up to a 5. 5. Okay, so I could write it like this. This would be acceptable. I could also write it in scientific notation. I could also go 9.5 times 10 to the 1, 2, 3, negative 3 grams of Fe. I could also do that. Okay? Or. Either or. Okay? Both would be considered correct. Okay? Okay. The U tries I'm going to have you guys do at the end. So let's flip. Okie doke. So this one says, how many atoms are in 4 moles of helium? How many atoms are in 4 moles of helium? So I'm going to take what I'm given, which is 4 moles of helium. Moles of helium. Now notice, in these ones we're going from moles to atoms, not moles to grams. Okay, take what I'm given, put it over 1. Same process. Because I have moles of helium here, moles of helium has to go down here. Same process. Now, whatever we're looking for goes on top. We're looking for atoms this time. We're looking for atoms of helium. So let's put atoms, atoms of helium. Okay, now where I see the word atoms, well, that's not grams, that's different. That's atoms. So let's look at the front. We know that when we see atoms, that's one of these guys, we need to use 6.022. So we're going from moles to atoms. We need 6.022 times 10 to the 23rd. And we know that 1 mole is equal to 6.022 times 10 to the 23rd particles or atoms. Okay, so that's what we're going to put. When we see the word atoms, we're going to put Avogadro's number, 6.022 times 10 to the 23rd. And again, wherever we see the word mole, we're going to put a 1. Okay? Let's put it in our calculator. So I'm going to go 4.00 times 6.022. And then remember, I use the E button. E stands for times 10 to the 23rd. Enter. And that's the number I get. So 2.4088. I'm going to write my unrounded answer first. Now, a lot of people forget. Notice, there's a little tiny times 10 to the 24th there. That's very small on a calculator, but that means you've got like 20 more zeros coming after this if I was to write it all out, not in scientific notation. So don't forget this. That's pretty much super duper important, right? Okay. Okay, so let's figure out how many sig figs we need. This one has 3 sig figs. So I need to round this to 3, so it's going to be 2.4, and then instead of 2.40, it's going to be 2.41, because the 8 is going to bump that up to a 1. Don't forget your times 10 to the 24th, and this would be atoms. Okay. All right. Let's do example number 5. It says a neon sign contains 2.01 times 10 to the 23rd atoms of the gas, meaning neon. How many moles of neon are in the sign? So we're going from atoms to moles. So let's take what we're given, 2.01 times 10 to the 23rd atoms of neon. Let's put Ne for neon. Take what we're given, put it over 1. Okay? Because I have atoms of neon here, I know atoms of neon go down here. Okay? Now, whatever I'm looking for goes on top. I'm looking for moles. So I'm going to put moles of neon right here. Now remember, wherever I see the word atoms, I'm going to use Avogadro's number, 6.022 times 10 to the 23rd. Wherever I see the word mole, I'm going to put a 1. Okay, now I'm going to calculate. 2.01 E23 divided by 6.022 E23. And I get 0.3. Again, I'm going to write my unrounded answer first. Okay. Now, how many sig figs do I need? I need 3 sig figs, because this right here is 3 sig figs. So I'm going to round that to 0.334. That 7 is going to bump it up to a 4 moles of neon. Okay. All right. And again, we're going to save the U tries for the end. Okie doke. Okay. Now, mass to atoms. Now, in this problem, for example, it says how many atoms are in an aluminum can that has a mass of 1.56 grams. So they took an aluminum can, stuck it on a balance. It says it's 1.56 grams. How many atoms of aluminum are in there? Okay. So we're given the mass, we need to find atoms. So this is not a one-step problem, this is a two-step problem. You need to go to moles, and then you need to go to atoms. So here's what we're going to do. We're going to take what we're given, grams of aluminum, right? Take what we're given, put it over 1. Okay, again, same steps. Grams of aluminum are here, so grams of aluminum need to go down here, so it cancels out. Now, we can't just go straight to atoms. We can't go straight to atoms. We have to go through moles first. It's like when you're on a flight and you have to have a layover, okay? Like if I want to fly to Paris, I can't get to Paris without going through maybe like New York City, okay? So I have to, this is like my layover. I got to go to the mole airport before I can go to my final destination, okay? Sorry, that analogy is maybe not great, but so I got to go to moles of aluminum. Once I'm in moles of aluminum, then I can take my moles of aluminum. Again, your diagonals need to match up. So because I have moles of aluminum here, I need to have moles of aluminum here, and then I can go to my atoms of aluminum. So a little hint. If you ever see a problem that does not say the word mole in the problem, does the word mole appear? No, the word mole does not appear. That means you're going to have 2 steps, okay? See, now here, the word mole was in the problem, and you only had 1 step. So, a little tricky trick for you. Okay, now, wherever I see G for grams, that tells me to go to the periodic table. Go to the periodic table, find aluminum, has a molar mass of 26.98. Okay, atoms, wherever I see the word atoms, I'm going to put Avogadro's number, 6.022 times 10 to the 23rd. And wherever I see the word mole, I'm going to put a 1. Cool? Cancel the things that cancel in your units, and then we're going to put all this in our calculator. So what we're going to do is we're going to go 156. I like to just multiply all the things that are on the top, divide all the things that are on the bottom. 156, and you can ignore the 1s, right, because they're not going to affect anything. So times my 6.022 times 10 to the 23rd, I use my E button. Then I'm going to press enter. Enter. Okay? Then I'm just going to press divide, and it'll store it for me. So I just go divide, and then I'm going to go 26.98. Enter. Okay, and this is what I get. So let me write down my unrounded answer here. Okay, let's see how many sig figs do we need. We need 3 sig figs. We need 3 sig figs. So I'm going to round this to 3.48 times 10 to the 24th atoms of aluminum. Kind of cool, huh? You can calculate exactly how many atoms of aluminum are in your soda can if you weigh it first. Or I should say, find the mass of it first. Okay? Okay, one more example. How many grams of magnesium are in 6.5 times 10 to the 25 atoms of magnesium? Okay, so this one we're going the other way around. We're given atoms, we're asked to find grams. Is the word mole anywhere in this problem? No. That means it's going to have 2 steps, or I guess 3 kind of things here. So let's take what we're given. Atoms of magnesium. Okay, take what we're given, put it over 1. Set up our first conversion factor. Because I have atoms of magnesium here, I know I need atoms of magnesium here because it needs to cancel out. So if I'm going to atoms, I'm eventually going to need to find grams. So I'm starting with atoms. I need to find grams. Before I can get there, I need to go through moles, and then I can go to grams. Okay, so I'm going to find moles of magnesium first. Notice I'm doing my units before. Don't put any numbers in until all your units are filled in, because that's how kids mess up, okay? Because I have moles of magnesium here, I'm going to put moles of magnesium here. And then whatever I'm looking for goes on top. I'm now looking for atoms. I can go from moles to atoms. So I'm going to put, I'm looking for, grams. My bad. Grams. So grams of magnesium goes there. Okay. Now, see how I have all my units laid out. Now I can fill in the numbers. Okay. So atoms, wherever I see the word atoms, that tells me I need to do Avogadro's numbers. That's 6.022 times 10 to the 23rd. Okay. And wherever I see grams, that tells me to go to the periodic table and I get 24.30 for magnesium. Wherever I see the word mole, I'm going to put a 1. Ta-da! Show your units canceling. Let's put it in our calculator. So I've got 6.5 E25. Remember, E stands for times 10 to the. Then I'm going to multiply by my 24.30. Then I'm going to press enter. And now I'm going to divide by the bottom. Divide by 6.022 E23. And enter. And that's what I get. I'm going to write my unrounded answer right here. 2,622.882763. Okay, how many sig figs do I need? I need 2 sig figs. That's only 2 sig figs. Okay, well, this is kind of weird, right? Because you've got something in the thousands here. So I only need 2 sig figs, so it's really going to be 2600 grams of magnesium. Don't put a decimal, because then that would make those zeros significant. But the way this is right here, it's 2 sig figs. Okay, so 2600. That's how you round it. I know it's weird, but that's the way you do it. Okay, now, here's the deal, guys. The rest of these U-tries you need to do on your own. Okay, do the rest of the U-tries on your own. And I put the answers down here, so you can check your answers to U-try 1, 2, 3, 4, 5, okay? The reason I give you the answers is so that you can see if you're doing it right or not. If you just write down the answer and don't show all your work, you will get 0 credit and it won't do you any good whatsoever. So you need to show all your work, all your work. I want to see all your work, okay? Meaning, perfectly laid out like this, units, substances, canceling of units, unrounded answers, rounded answers, all the things we just did, I need to see on each and every one of these U-tries. There's only 5 problems, okay? Do that, and then there's an assignment where you can submit it.